So today we'll start machine learning in Python. So first of all, what about the machine learning? Machine learning, before we start, we know about the basic Python. Okay, so machine learning is a making the computer learn from studying data and statics. Machine learning is a step into the direction of artificial intelligence, AI. Machine learning is a program that analyzes data and learns to predict the outcome. Then, where to start? How can we start machine learning? So, basics, mathematics and study of statics, and how to calculate important numbers based on data sets. So Python module give it is help to you how can we work the functions, how to predict the outcome based on the live we learn. So first we'll move data set. Okay, so in a computer a data set is a collection of data. It can be anything from any from an array to a complete database. Okay, suppose example like that we are taking some initial value, 1 to 20 or either something else. So this is the array, so we can guess the average value in probably around what will be coming out of. So we are able to determine the highest value and lowest value. But what else can we do? But हम और क्या कर सकते हैं? So database we can see the most popular things, and like, so in a machine learning it's a common to work with a very large data set. Okay, so mostly use a big data. Okay, machine learning. So now data set, that means you can understand collection of data. It can be anything from array or array can be there, variable data, some single data will be there, maybe multiple data will be there. Okay, so that is a complete database and mostly used to a big data, that is a part of machine learning. So now we'll move to next topic, data types, and how many types of data types in machine learning. So now next move, these are the data types. So data types mainly used to analyze the data. It is important to know what type of data we are dealing with. So we can split the data types into three main categories. One is numerical, second one is categorical, and third one is ordinal. So we'll talk about numerical. Okay, so three type of basic data types in machine learning: numerical, categorical, and ordinal. Okay, so now we'll move first one, numerical data. Numerical data are the numbers and can be split into two numerical categories. Okay, so numerical data mainly are numbers and can be split into two numerical categories: discrete data and continuous data. So we'll talk about discrete data. So discrete data, that means numbers that are limited to integers. Okay, so number of cars, number of bike, number of fan, number of monitor, number of computer, so that are the limited value of the integer. So that is a discrete data. If we talk about continuous data, so number that are of infinite value, like the price of an item or the size of an item. Price may be 1 crore, 2 crore, 10 rupees, 1 rupees. A number of infinite value will be there. So categorical data are okay. So these are the two numerical data, numbers data. Discrete, that means a limited number of integers. Continuous, that means an infinite number of infinite value we can access, like a size and price of item, size of item. These are the continuous data. So now we'll move next, categorical data. Categorical data are values that cannot be measured. Values that can be that can't be measured up against each other. This example, like a color value or any yes or no values, or either true or false, we cannot measure. It is just possible values. Okay, binary will is 0 and 1. So now we'll move ordinal data. So ordinal data like categorical data but can be measured. Ordinal data are like a categorical data but can be measured up against each other. School grades, A is better than B and B is better than C. So A and C is better than D. so and so on type of grade. So just like a categorical data, but we can measure, that means we can call it ordinal data. Okay, so by knowing of the data types source, so technique we are use analyzing them. Okay, so these are the data types in machine learning. So three types of data types we are having in machine learning. So we know about the first things of like that machine learning. So machine learning is very important part: mean, median and mode. Okay, so mean, median and mode. Mean, median and mode. So what can we learn from looking at a group of numbers? In machine learning and mathematics, there are often three values that interest us: mean, the average value; median, the midpoint value; mode, the most common value. Example, we have registered the speed of 13 cars, yeah, either we have registered the grade of 14 students. We have count the speed of the ball. So that is the mode, median. So speed and so mainly calculate the speed. Okay, so now before we move standard deviation, I'll just show the practical. Okay, so first practical is like that: mean, median and mode. So we'll move like that. Before we just okay, so first we will have to import numpy. Okay, so import numpy. Okay, then second, suppose I'm taking a variable speedy, speed either okay, so thus I'm taking a value 99, 878, 87, 65, 30. Okay, 89, 123, 101, 145, 159 and 45 and 658, so and 78. Okay, so these are the value we are taking. Okay, so okay, this is the variable and we assign it like a data. So we are taking another variable just like a data. Okay, so data will be calculate numpy dot mean, and which mean speed. Okay, now print of data. Now you can see that what will be output is there. Okay, that is a mean of that. Okay, so now we can calculate like that median of data. How can we? Just simple data equals to numpy dot median of speed and print of data. So you can see that median of data, so total. Okay, so now after that we can calculate next one is the mean, median, mode. So mode basically if there are two numbers in the middle, divide the sum of those number by 2. Okay, so that will be show the median. Okay, first. Okay, now we'll talk about mode. The mode value is the value that appear the most number of times. That means repeating of the value. So just I'm copy wait. Okay, so we are finding mode and we have to give some value, repeated value 65, 78, 56 and 89. Okay, so now I just whatever mode, mode mode, and so okay, so what we do now, because our mode method find the numbers, so basically we have to import header file, import numpy as np, either numpy lit and numpy. Okay, and import sci-fi wait from sci sci-fi, import stats statics. Okay, stats. So now stats it's here. So now we'll move. Okay, stats stats. Now you can see the data output of this. So mode will be printed here, so wait and watch, so that we can find out the mode of the value. Okay, so now we'll move. Okay, so mode result of 78 and count array of 3. So 78, 78 and 78. So okay, so repeating value, it will just like show a mode in a statics manner. Okay, either mode it will show the remainder, but we are in statics form, so that is the part of this thing. So basically mode, the most common value we are finding this like that. So most common value is 78 in this. Okay, so now we'll move a standard deviation. Okay, so standard deviation, that means standard deviation is a number that describe how spread out the values are. A low standard deviation means that most of the number are close to mean average value. If a high standard deviation means that our value are spread out over a wider range. So example, like again you can see that speed of variable. So now suppose speed deviation, that means meaning the most of the values are within the range of divided by suppose the range of in this scenario. So we can see that. Okay, so meaning the most of the value are within the range of something means mean value, and which are higher standard deviation indicate the values are spread out over a wider range. So NumPy module has a method to calculate standard deviation. So how can we calculate? Just see that suppose paste it over here, our list is there. Okay, so I just remove 4 lines. Okay, so now import NumPy. Okay, so NumPy, that standard deviation, that means std we have to press and print out of data. So you can see that standard deviation of in NumPy module. Okay, so that is a part of NumPy module. So we can see that in this manner. So the standard deviation is there. Now we'll move next. What a percentile? So percentile, that means a percentile are used in a statics to give you a number that describe the value that a given percent of the values are lower than. Okay, so given percent of the value. So we'll talk about sorry, before mu one thing, I think standard deviation. So we'll talk about variance. Okay, standard deviation. We are IANC variance. So what is variance? Variance is another number that indicate how spread out the values are. That means suppose you are taking square root of the variance, so you get the standard deviation. So how can we find? That is very simple. Suppose I am just creating a number, suppose 32 plus 42. Let me just plus 32 plus 42 plus 8 minute comma 42 plus 56 plus 66 plus 78 plus 86 plus 96. Okay, these are the value, and just divide by, suppose number of value 1 2 3 4 5 6 7. So divide by 7. Okay, and suppose we are just dividing by 7, and we can see the output if he is coming. So that is the output of 65 point something. So that is a variance. So for how can we find each variance of this? Okay, so for each variance, that is the find of a square value. So the variance is the average number of these square differences. So now how can we find it? Just simple. How can we find the variance? That is simple. So just paste it over here. Our list is, I am just pasting. Okay, so okay, wait. Yes, import NumPy, and now data. So data df. Okay, so now I am making df. Suppose 32 comma 42 56 comma 66 comma 78 comma 86 comma 96. Okay, now data equals to NumPy dot var, and now df we are putting over here, and now print data. Okay, now you can see that variance of the task. So we'll have to just square each of them, and then we can find out the variance of this one. So standard deviation of this one is, suppose output is our output is this, so we can find out our standard deviation. So now standard deviation is often a representative of the sigma symbol. Okay, so mainly if you talk about STNDR is standard. Okay, standard deviation deviation symbol. So symbol is sigma. Okay, sigma symbol we calculate, and variance. So variance is calculate in that manner. So square symbol. Okay, so square symbol we are using in variance. Okay, so now we'll move next topic is this percentile. So percentile are used to statics to give a number that describe the value that a given percent of the values are lower than. Okay, so how can you find out percentile? Percentile, that means used in statics to give you a number that describe the value. So suppose I am just putting suppose marks. Okay, so marks is the variable. Okay, so I am just putting it here. Suppose 32, 42, 52, 62, 72, 82 and 92, and okay, and 96 and 88. So these are the marks we are having. Okay, list. So how can we calculate? So numpy having a percentile method to find percentile. So simple, already we have to import numpy. Okay, and now data is equals to numpy dot percentile percentile, and we are using marks. Okay, so marks, and suppose so in percentile manner, suppose okay, so we can find out suppose I want to see the what about the 90%. Okay, so I am just putting it 90. Okay, so after 90 putting, just see the print function of data, print data, and what see the output. So 92 is the marks, and the percentage will be nearby, and 90. So that is the percentile option. Okay, now we'll talk about data distribution. So that is very important topic in machine learning. Data distribution. So data distribution, that means small amount, a very small amount of data suppose we are having. So that is different concept. So now we'll talk about in the real world, the data set are much bigger, but it can be difficult to gather real world data. So at least at an early stage of our project and our features, so that is used to data distribution techniques. So if we are having a large data, that means we can get a big data set. So how can we create a big data set in suppose testing set, training set? So Python module numpy, which comes in the number of method, create a random data set any size. So how can we create? Suppose we are creating random data sets in Python. So first suppose import numpy data is equals to numpy dot random dot uniform, and suppose we are giving a value suppose 0.0 and 6.0 and 350 numbers we are having. Okay, so now print of data, and now you can see that that is a data set we create. If you want to see a large data set, so that means suppose I'm just putting 3050. Okay, so okay, data set will be missing. Okay, so that is a data sets of variance in number of records. So we can see that, find out number of data in. So in dataset I want to see a histogram in data distribution. So to how to visualize, dataset, so we can draw a histogram with the data we are collected. Okay, so we are using matplotlib. So visualize data, how can we? A simple import numpy and then import matplotlib.pyplot as a plt. Okay, so now data, okay, so data is equals to numpy dot random dot uniform, and this giving our 0.0 comma 0.6 comma 450, and now plt dot hist of data comma 5, suppose I'm putting 6, sorry, and plt dot show. Okay, now key, so you can see that visualize our data, it will be like that, and 0.6, suppose I am just putting in here 0.8. okay, 0.8, so okay, so it will be reflected like this. Okay, so histogram, I just explained the histogram. Suppose we are using in this array 8 bar. Okay, so first bar represent the how many values in the array between 0 and 1. Second bar represent how many values are between 1 and 2. Third value 2 and 3, 4, 3 and 4. So each and another. So which will value in the result, if it shows, so 0 to 1, you can see that about 60 to 80, between 60 to 80, 65 to 80, and suppose we want to see the number of value. So now we'll talk about big data distribution. Okay, so big data distribution, suppose we are having 450 values, it is not considered very big as a small amount of data, but you know how to create a random set values. So simple, I'm just creating a large value in that manner. Okay, so import numpy, import matplotlib dot pyplot as a plt, and data equals to numpy dot random dot uniform. Okay, so 0 0.0, 0 0.5 and 10,000. Okay, that is the big data. Okay, so now plt dot hist and data comma value will be then 1000, and plt dot show, that is a big data. I think this is a database of high value. Okay, so okay, uniform, okay, uniform. So now you can see that 1000 value will be there. So that is a big data set we are creating over here in data distribution. So next class I'll show you a different type of thing in machine learning, normal data distribution. If you like that code and theory, and so please subscribe my channel and share my channel. Thank you, have a nice day, bye bye.